Hello, I'm going to talk about the conservation of energy. Here we're going to have an interplay between the gravitational potential energy, which is equal to the weight times the height of an object. I'm going to use this ball here on this track. This is a loop-the-loop, similar to the loop-the-loop rides that we see at the amusement parks. Now, as this object starts at a certain height, with respect to the bottom point here as a reference point, it'll have a certain potential energy. And that potential energy will be equal to the weight times the height of this object. And so the higher the object is, the more potential energy it will have. Notice what happens when the object starts at a certain height here and rolls along the track. As its potential energy decreases, its kinetic energy, which is related to the speed, will increase. So the speed will increase as the height decreases. Now at the bottom of the track it'll have minimum potential energy, so that's where the kinetic energy will be a maximum. It'll be moving fastest at the bottom of the track. And then as it tries to climb back up the hill here again, it will lose kinetic energy as it gains gravitational potential energy, so that at each point in the motion its total energy will be the same as it was initially, illustrating that the total energy remains constant. Let me start it here at a height equal to the height of the top of this loop here, and let's see what happens. Well, you might have guessed that would happen, because if you think about it carefully, it has a certain amount of potential energy to start with, and when it gets to this point here and starts to leave the loop, we find it doesn't have enough total energy to retain its kinetic energy and make it up to the top of the path. So it has insufficient energy to make it up here and still be moving, because its total energy to start with has to remain constant throughout the motion. Simply doesn't have enough energy to get up here and still be moving. Now if I start it higher, then maybe it'll have enough kinetic energy when it gets to this point, even though it's going to lose some potential energy as it's going to gain potential energy as it goes from here up to here. And it'll lose kinetic energy, but maybe it'll still have enough to make it around the loop. Let's see what happens here. So try that one more time. And we see that indeed, if I start it high enough, then it'll have sufficient energy to get to this point here and still have enough kinetic energy to make it over the loop and come off the end. This will also work with a steel ball. Details are just a little bit different, but a steel ball will illustrate the same principle. Total energy remains constant throughout the motion as potential energy gets converted to kinetic energy and then back to potential energy again.